And welcome back to another LeetCode video. Today we're looking at a problem. It's 3309. Adjacent increasing subarray detection. Right, so let's just dive into this problem and then come up with this. So we're given an array nums of n integers and an integer k. And we should determine whether there exists two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, to check if there are two subarrays starting at A and B, where A is smaller than B, where both subarrays from A to A plus K and B to B K are strictly increasing. The subarrays must be adjacent, meaning the starting position of the second subarray must be starting position of the first one plus return true if it's possible to find such subarrays and false otherwise. Interesting, and we know that we are given at least two elements in our numbers array, and k is going to be, well, k is going to be an even number. No, wait a second. K is going to be any number, but it's going to be larger than 1 and smaller than the length of the array divided by 2. The numbers can be positive and cool. How could we approach this? Well, one approach would be to find an increasing, well, to first find an increasing subarray and then check if another one exists just next to it. But I think there's an easier way where we only have to loop over the array one time. Because we know that the subarrays must be adjacent, but immediately check if we are currently in an increasing subarray, and then also if at distance k we also have an increasing subarray. And then we just iterate over all of our numbers and nums. And when we find that we have k times, we have k different positions, we have an increasing subarray, both in the left and the right subarray, we know that we have turned true because we found the two subarrays. So let's look at an example here. We have the subarray starting at index 2, 7, 8, 9, and we have another subarray starting at index 5 adjacent to it. So that would be, yeah, a valid, well, that would be the detection of two subarrays that are adjacent to each other. So how do we put this into code? Well, we need to loop over the numbers in the array, and we could use a for loop. But since we're doing some indexing arithmetic, I think it would be better if we just use a while loop and we just track of our index manually. So let's do it like this. For while, well, what do we have to check? Well, we have to check that I is smaller than the length of nums. That's one thing. But we want to check if nums at I is smaller than nums at I plus 1. Right, so this is the first condition that matters. This would be to check whether in the first subarray we have an increasing two consecutive numbers, and we also need to check that in the possibly adjacent subarray that has the same property. So we have to add k onto that. Plus 1, right? And so that means now while loop we have to check whether I is smaller, well, I plus k plus 1 is smaller than the numbers, otherwise we would get an index out of bound exception right here. So what do we do then? Well, in this case it means, well, we found that that we have two consecutive numbers in both the current position I and I plus 1 that are increasing, and also at position I plus k and I plus k plus 1. So we'll increase our counter plus 1 match. And well, if we've reached the maximum, which is counter k minus 1, if we found, that basically means we found k numbers that are in increasing order in both of the subarrays. Well, in this case we can just return true. And it's k minus 1 because we are comparing two numbers, and we only need k minus 1 comparison for this to succeed. Not actually k consecutive numbers, both of subarrays that we're increasing. Now, if this condition doesn't hold, that means, well, subarray that we were in isn't continuing to be increasing, so we have to reset our counter to 0. Right, and then we can increment our variable. Now, we could also write this as a for loop for I in go, or length nums minus whatever. Let's keep it this way. And well, otherwise, if we never find a subarray of that required length, we just return false. Now there's one more edge case which is we know that length of nums is always, what to say, 2 or larger. But if k is 1 and we have an array of length 2, well, then we have a problem because we'll never get into the while loop. I 1 plus 1 is 2, and so length of the array is 2. We will immediately false. However, when we have an array of length 2 in case 1, then both are subarrays in increasing order, even though they only contain one element. So that is an edge case that we have to take care of, and we'll just have a little check. So if k is equal to 1, return length of is larger than 2, which it is, so we just return true. The reason for why this is an edge case is because we need two numbers to be able to compare them. Two numbers in each of the. So the total length of nums is 2, and there's only going to be subarray. That's the edge. Right, so let's run the test. And we're getting error, nums. So that works, and this works. Meanwhile, we should have a look at the runtime and space complexity. So in terms of runtime, well, that entirely depends on the length of nums, right? So of and time, and well, how much space, and well, constant space, because we're not really storing anything except for the counter variable or the index space. Right, so that's how to solve this problem. That explains why it's an easy one, straightforward solve. Interesting. Two inequalities. Time. Do that, it becomes really